Here we consider a class of lexical items or collocations of lexical items whose grammar appears to be sensitive to either negation or negative-like elements in their environment. So there's a vast class of things of these expressions that are often called negative polarity items, and their distribution and the reasons for why they have this particular distribution is a puzzle that has long attracted the attention of linguists, in particular researchers in both linguistic semantics as well as natural language syntax. Now, what are negative polarity items and what exactly is puzzling about them? Negative polarity items are a class of that are said to live in the shade of negation, so to speak. It's either morphologically explicit negation, negative adverbial or adjective, or a negative implicature. To give just a few examples from English, take the English words ever and any. These appear in these are perfectly acceptable in sentences that contain negation. For example, if I say Kumbhakarna won't ever wake up and Kumbhakarna doesn't have any friends, they're both good sentences. But Kumbhakarna will ever wake up and Kumbhakarna has any friends are both ungrammatical sentences. Now, what is it that's puzzling about negative polarity items? So the first account of or the first description of negative polarity items that you can find in modern linguistics is the work of the syntactician Edward Klima, who noticed that there is a class of environments in which in some sense license negative polarity items. The term used by Klima was the term he used was affective. Okay, so these are certain kinds of environments called affective environments that license negative polarity items. Negation is one affective item, but negation is not the only affective element. So, for example, questions, conditionals, some quantifiers, but not others, are all environments that license negative NPI. Negative polarity items are often abbreviated with the term NPI. So every time I say NPI, you know what I mean. So consider these examples. These are all grammatical sentences. Will Kumbhakarna ever wake up? Does Kumbhakarna have any friends? They're both fine. Questions, at least yes, no questions, do license NPIs. If Kumbhakarna ever wakes up, I will feed him. If Kumbhakarna has any friends, they should wake him up. So the antecedent of a conditional is also an environment that licenses NPIs. Every Rakshasa that has ever tried to wake Kumbhakarna up has failed. Every Rakshasa that has any friends does not snow. So the restriction of every is also another affective item. However, every is crucially different from some. So some Rakshasa has ever tried to wake Kumbhakarna up has failed is an ungrammatical sentence, as is some Rakshasa that has any friends does not snow, which is also an ungrammatical sentence. So Klima, in one of the earliest proponents of a theory of NPIs, proposed that they must be in construction with a trigger that is either overt negation or an affective element. So Klima's account was simply to say that there are some things that contain a syntactic feature plus affective, and negative polarity items are required to be in construction with these affective items. Okay. However, this doesn't have much explanatory power besides incorporating the descriptive generalization into a syntactic licensing condition. There are also some other problems that you can think about. For example, why does every license NPIs in its restriction but not in its scope? So there are some problems like now the first serious account towards a proper characterization that simply didn't built in that didn't simply assign a feature plus something syntactically comes from the work of Fauconnier and Lajussard. Fauconnier 75-78 and Lajussard 1979 approached the matter from a semantic angle and noted that NPI licensing contexts share a subtle and deep logical property, and that property is downward entailment. To understand downward entailment, we take a word which expresses a property and compare it with other words that express a subproperty, hyponym, or a superproperty, hypernym. For example, carrot expresses a subproperty of vegetable because every carrot is a vegetable, but it's not true that every vegetable is a carrot. Food is a superproperty of vegetable. So a simple, non-negative, non-quantified declarative sentence that allows inferences from properties to superproperties. This is called upward entailment. So if I say Kumbhakarna ate a carrot, it entails that Kumbhakarna ate a vegetable. The logical feature of not and most basic NPI licensors is that it reverses this inference pattern, creating environments that are not upward entailing, but have the opposite property. And that's the property that we call downward entailment. So it's often also called downward monotone or downward entailing. These are used interchangeably. So whereas Kumbhakarna ate a carrot entails that Kumbhakarna ate a vegetable, Kumbhakarna ate a vegetable does not entail that Kumbhakarna ate a carrot. However, Kumbhakarna did not eat a vegetable does entail Kumbhakarna did not eat a carrot. In other words, what negation does is reverse the entailment pattern. Now, if you take a sentence with a quantifier of the form determiner, restriction, predicate, and check where an NPI can occur in this structure, you again get the following pattern. Every Rakshasa that has ever tried to wake Kumbhakarna up failed. No Rakshasa that has ever tried to wake Kumbhakarna up has failed. They are both, in other words, NPIs are good in the restriction, both of the determiner every as well as the determiner no. Which determiners do not allow negative polarity items in their restriction? Some and three are some examples. Some Rakshasa that has ever tried to wake Kumbhakarna up has failed is a bad sentence. Three Rakshasas that have ever tried to wake Kumbhakarna up have failed is also a bad sentence. Now, so far we're taking a look at the restriction. Now, let's look at the predicate. What is an example of a determiner that allows an NPI in the predicate part of the statement that contains it? Suppose I say no Rakshasa has ever tried to wake Kumbhakarna up. That's a good sentence. But what are those cases where NPIs are bad in the predicate part? some Rakshasas has ever tried to wake Kumbhakarna up is a bad sentence. 3 Rakshasas have ever tried to wake Kumbhakarna up is again a bad sentence. Every Rakshasa has ever tried to wake Kumbhakarna up is also a bad sentence. Now, the above data shows us that an NPI is acceptable inside the restriction of every, but not in its predicate. It is acceptable in both the restriction and predicate of no. It is bad in both the restriction and predicate of some and 3. Now, with respect to the property of downward entailingness, the restrictions and predicates of these quantifiers show the following pattern. Every creature snores entails every Rakshasa snores. This shows that every is DE, downward entailing with respect to restriction. Every Rakshasa snore does not entail every Rakshasa snores loudly. That means every is not downward entailing with respect to the predicate. Some creature snores does not entail some Rakshasa snores. That means some is not downward entailing with respect to restriction. Some Rakshasa snores does not entail some Rakshasa snores loudly. And some is not DE with respect to predicate. No creature snores entails no Rakshasa snores. That means no is downward entailing with respect to restriction. No Rakshasa snores entails no Rakshasa snores loudly. That means no is DE with respect to predicate. 3 creatures snore does not entail 3 Rakshasas snore. That means 3 is not downward entailing with respect to restriction. 3 Rakshasas snore does not entail 3 Rakshasas snore loudly. That means 3 is not downward entailing with respect to the predicate. So you can see this in the following table. You look at every no, some, 3 with respect to the restriction, with respect to the predicate, and you will see that whether the environment is downward entailing or not neatly coincides with whether NPIs are licensed in these environments or not. So this is a remarkable result, okay, making it clear that the environments that are downward entailing are precisely the context where NPIs are licensed, and so this is what Ladouceur proposed. Ladouceur proposed that NPIs were sensitive to a certain logical property of certain kinds of environments. So his licensing condition was the following. Alpha is a trigger for a negative polarity item in its scope if and only if alpha is downward entailing. Now, it was soon observed that this was fine for any and ever, but there are also other kinds of lexical items that seem to be even more restricted than the noun phrase than any and ever, and so something needs to be said about that. So here we come back to the work of the linguist Franz Schwarz, who observed that there are not all licensors of any and ever are alike, in the sense that there are how negative something is depends on some other logical properties over and above downward entailing. So Schwarz came up with the notion that negations or negative environments or affective environments have various strengths. So one of the things he observed was that you could think, you could basically say that there is a logical property that's called anti-additivity, and it looks like that there are some negative polarity items that are sensitive not just to downward entailingness, but to slightly stronger conditions. One such condition Schwarz proposed was the property of anti-additivity. Now, the logical property of anti-additivity is as follows. Okay, we say that a licensing environment is anti-additive if and only if W, X or Y, Z is logically equivalent to WXZ and WYZ. What's an example of an anti-additive environment? The determiner no in its restriction is an example of an anti-additive operator. No one sang, or in both its restriction as well as its scope, as well as its predicate part, is anti-additive. So consider no one sang or danced last night, you can notice is logically equivalent to no one sang last night and no one danced last night. Similarly, so now no is in fact anti-additive in that part. Now licensors like not support DE, anti-additivity, and even stronger property that Schwartz called antimorphicity. The logical property of antimorphicity is the following: W, X and Y, Z, if and only if WXZ or WYZ. Suppose I say John did not smoke and drink last night. That's logically equivalent to John did not smoke last night, or John did not drink last night. Now, on the basis of their ability to license different inference patterns, Schwartz proposed a hierarchy. So pointed out that there is in fact a hierarchy of negative expressions. Minimal negation is simply all those environments is expressed simply by all those environments that are downward entailing. What are examples of minimal negation? Few, at most, hardly, at least, and so on. What is regular negation? Regular negation are environments that are both downward entailing and anti-additive. I should point out, by the way, that all anti-additive environments are by definition downward entailing. This is something that you can prove logically. It's a fairly simple proof. Now, what are examples of regular negation? Regular negation are things like never, nothing, before, without, and so on. The restriction of the universal determiner is also anti-additive. So the restriction of anti-additive in fact patterns with regular negation in this respect. What about classical negation? Well, classical negation are those environments that are downward entailing, anti-additive, as well as antimorphic. An example of a classical negation would be not the English, the pure negation or whatever is expressed by the English not, and its counterpart in various other languages. Now, what Schwartz proposed was the following. A minimal negation, he said, licenses a class of NPIs that he called weak NPIs. Regular negation licenses what he called strong NPI. Classical negation licenses what he called super strong NPI. NPIs, like any and ever, are weak as they occur in DE environments. NPIs, like in years, are strong as they occur in anti-additive environments. NPIs, like 1 bit, are super strong as they occur in antimorphic contexts. So, for example, everyone who liked John 1 bit is not a good sentence, but I didn't like John 1 bit is a good sentence. Everyone who likes John 1 bit is not a good sentence. 1 bit is super strong. No one ever likes John 1 bit is people have different intuitions on this, but the people, for those speakers of English who do not like it particularly, this would be because never is, it's an anti-additive environment, but it's not antimorphic. Now, this particular classification works so well for lots of NPIs and many languages. Some NPIs cross-cut the classes, showing licensing patterns where they're good in a combination of some AA and DD and AM context and not others, thus eluding a clear logical solution. Linebarger, both in her thesis and the paper, at one point pointed out that many NPI licensing contexts were not really downward entailing. They were not really downward entailing if you went too literally. Okay, so the antecedent or protasis of conditionals, adversative predicates like be surprised, questions, imperatives, modal verbs, habituals, disjunction, etc., are not downward entailing, but at least under certain conditions, license NPIs. Now, she proposed a solution based on negative implicatures and pragmatics. Okay, the primary licensing mechanism for NPIs is still negation. NPIs should always be in the immediate scope in the logical form of negation. When there is no overt negation, a pragmatic derivative licensing mechanism kicks in, allowing environments that express a negative implicature through sentential negation to license an NPI. Okay, so examples of this would be the following. Kumbhakarna was surprised that there was any food left. Kumbhakarna expected that there would be no food left. So, on her account, the reason why surprise licenses NPIs is because every time you say Kumbhakarna was surprised that P, there is an implicature associated with that says Kumbhakarna expected that not P. And because not is a negative element, negative polarity items are licensed in that particular circumstance. Okay. Now, as was immediately observed when this proposal was made, this approach overgenerates. There are environments that give rise to negative implicatures, but do not license NPIs. Kitna time? One attempt to basically plug the holes in the benchmark theory of NPI licensing by Fauconnier and Ladouceur was made by Kai von Fintel, who introduced the notion of Strawson entailment. I should also point out that the germ of the idea behind Strawson entailment already appears in an old paper by Bill Ladouceur, which he wrote in 1982 at some point, a few years after his thesis came out, where he suggested that when you're computing downward entailment, you should keep in mind certain things. Basically, you should keep in mind, you should keep in under consideration, you should evaluate downward inferences by keeping constant, by considering only those situations where the presuppositions of a certain environment are satisfied. Now, von Fintel came up with a notion that's called Strawson downward entailing. So, on von Fintel's account, a function f of the type sigma tau is Strawson dE if and only if for all xy of type sigma such that x entails y and f of x is defined, fy entails f of x. Now, by f of x is defined, what von Fintel is assuming that the presuppositions associated with the function are in fact satisfied. So this assumes a theory of presuppositions according to which if you have an environment that triggers certain presuppositions, then whenever there is a presupposition failure, the semantic value of f applied to x, f of x is basically undefined, when there's a presupposition failure, whenever the presuppositions are satisfied, f of x could be could have the value whatever it does. So it will be true or false, or if it's some other kind of semantic value, you'll consider some other whatever the semantic value. Okay, so basically Strawson downward entailingness checks DE with the additional premise that the conclusion has a definite semantic value. An NPI licenser like only is problematic for DE, but with Strawson downward entailingness, it no longer is, because the new inference schema is slightly different. You only so let us look at the following example. Only Kumbhakarna ate a human. Kumbhakarna ate a priest. Only Kumbhakarna ate a priest. Now, when you say only Kumbhakarna ate a human, that carries the presupposition that Kumbhakarna in fact ate a human. You will only consider those circumstances where Kumbhakarna in fact ate a human. Now we know that priests are human beings. So if only Kumbhakarna ate a human and Kumbhakarna ate a priest, it follows that and because priests are humans and only Kumbhakarna ate a priest, it follows that only Kumbhakarna ate a priest. Now, what Strawson downward entailing does is it helps in bringing the recalcitrant cases of adversative predicates and conditionals into the fold of semantic entailment theory. The one with conditionals is a little bit more complicated, but that's what you can do.